Hey there, this is a video that introduces you to setting up Graphical Modeler. We're going to do the first steps of working with some data that we're going to download from OpenStreetMap, downloading the data and creating parameters in the Graphical Modeler in QGIS, and then doing a quick buffer of those data to remove any topology errors. So Graphical Modeler is helpful for creating a reproducible process. You can create a script or a set of functions that if the data changes, or if you want to run this analysis again for another city, you can just go ahead and just run it. You don't have to click on the 5 or 6 different things that you had to do to create this process. It also allows you to share your process with others. So in this case, what we're going to do is we're going to take the Milwaukee MSA boundaries, Metropolitan Statistical Area boundaries. And this just looks like a polygon right now. Let's kind of get some context for this polygon. I'm going to use Quick Map Services to add the OpenStreetMap base map. And then I'm going to make this polygon transparent. And I'm going to do that by clicking on Simple Fill and going under Fill Color and choosing Transparent Fill. Click OK. You'll notice that the text here looks a little weird. Let's change the projection over to a web Mercator, which is right here. It's pseudo Mercator 3857 in QGIS. And you can see, there we go. That looks a lot more readable, right? And so you can see kind of where we're at. Here's Milwaukee, and the boundary of the Metropolitan Statistical Area is right here. Great. So let's go ahead and then download our OpenStreetMap data. We're going to do that using the Quick OSM plugin, which we added in a previous assignment. This is for GEOG 2011 at University of Georgia. You can go under Plugins, Manage Install Plugins, and download Quick OSM. And you get a window that looks like this. And so we are going to, in this case, download all the leisure sites. And this includes a lot of different things, which we'll see in a second. And then we want to do in the layer extent of the Milwaukee MSA. And we'll go ahead and run that. It's going to take a second because it's going to download all the polygons and lines and points within the Milwaukee MSA. It's not a huge data set, but it takes a second to download. The leisure points are going to be things like everything ranging from parks to biking infrastructure to I forget what all. We'll find out when it all gets down there. We'll look at the attribute table together, and then there we go. That was relatively quick. So you see there's points, lines, and polygons. For this analysis, I'm going to avoid the points and lines, and we're just going to look at the polygons here. And you can see there's a bunch of them. It's only for anything that's inside the MSA. It was downloaded. We can open up the attribute table. That will take a second too. There's 6,102 features. And the type of feature is listed under leisure. So I'm going to go ahead and sort by leisure, and you'll see some of them are blank. They're just listed. It's listed as blank. But there's things like bandstands, a lot of bleachers, dog parks, fire pits, gardens, right? If we keep scrolling down here, outdoor seating, parks is what we're going to look at, I think. Pitches, I'm not sure what a pitch would be. We'd have to take a look at that. Playground, swimming pools, and tracks and water parks, right? So there's a real variety of things in here, but that's in essence what we're looking at. So the task at hand eventually in the assignment that this video is for is I'm asking folks to create a buffer of a certain distance around park areas to see what areas of the MSA are covered within, say, a half mile of this. To do that, we're going to create a graphical modeler, or create a model using Graphical Modeler. So we'll go ahead and click on Graphical Modeler here. And what you'll see listed is that we've got inputs and algorithms. Inputs are kind of the things that are going to go into the model, the parameters for the model, and the algorithms are the functions. It's the kind of the verbs. These are the nouns, these are the verbs of the model, right? So let's just start with a vector layer. That would be our leisure polygons data set, right? So let's put vector layer over here. And in fact, we'll call it OSM polygons. And click OK. It's mandatory. This is essential to the model, so people have to enter that in there, right? We're also going to want to, let's say we're going to do a clip eventually, right? Or a buffer eventually. We might want to add in something like a number. So if we're going to do a buffer, we might want what the buffer size is going to be, and that's a number, right? And we can say, is it a float or an integer? Float just means it's a decimal, and we'll say yes to that, right? So let's just start with that. And then we'll take our algorithms here, And let's look for, the first thing we're going to want to do is maybe correct for some topology errors. So I'm going to search for buffer, and if I go to the top, it's just buffer. I'm going to scroll that over here. Now what that means is simply when we download these data from OpenStreetMap, some of them might have topology errors, meaning the polygons weren't drawn just right. And QGIS doesn't like that. Sometimes if there's topology errors, it'll just tell you there's a topology error, you need to fix it. One easy, quick way to fix it, it's not the most thorough, but it kind of just does the trick, is to create a buffer. That is, add some space. Technically, you're supposed to add some space around something, buffer around it. But in this case, we're going to buffer and have the distance be 0, right? Because basically we want it to stay the same size, but in doing that buffer, QGIS will automatically correct any topology errors in there. So we're going to say the distance for this buffer is 0. We want the input layer. We don't want it to be this leisure layer. We do, but we want to leave that as an option, right? So what I choose here instead is model input, meaning it's one of these nouns over here, right? And it's the OSM polygons. And we're going to buffer it to 0. Everything else we can stay the same. If we wanted to have this be a file, we could type in, or actually not a file, if we wanted this to be a layer that's added to the layers down here, we could say that. In fact, let's go ahead and do that. Something like that, right? There we go. And now you can see we've added buffer. It pulls in the OSM polygons and it gives us a buffered result, right? So let's just kind of run that. I'll hit run. It'll open a box. You'll notice this looks like almost any other function that you run in QGIS. So my buffer size right now is 0. That actually doesn't matter. We can use that later. I'll leave it at 0 for now. And my OSM polygons, I want the leisure polygons. I'll just create a temporary layer for now. And I click run. And let's see. Looks like it worked, right? So if I minimize this and go down here, oh, there we go. It does look like it removed some of the polygons here, and I'd have to go back and investigate that. But it gives you an idea of how this function works. So if we were going to add in another function, just to give you a sense of how this would operate, let's say we wanted to do a clip after this. We would simply add clip, scroll it down here, and here's my clip. And I would take as my input layer, in this case, an algorithm output. So that's an output from a previous function. In this case, I would take the buffered result from buffer, right, and put that in here. And that is going to clip the results. That is, it is going to trim anything that's outside of another polygon. The overlay layer that I want to clip with, basically the thing I want to put on there, is going to be the Milwaukee MSA. And you'll see what this means in a second. So I'm going to put in clipped here. And now you'll see that my model no longer has something coming out from buffer. And in fact, if I click on this, you'll see down at the bottom, oops. You'll see down at the bottom, there's nothing in here right now. Instead, it just goes automatically then into this clip function, and it does the clip, and then it ends up with an object at the end called clipped. So I'm going to put that in here again. I'm going to choose all the same things. I'm going to go ahead and run it. And one of the things you'll notice now when we look at these results is that when I scroll out, see these areas that are outside that polygon got cut away. So if I just look at the clipped results, all I get are the areas that are inside that polygon. So you can keep adding functions that way. You can create a whole chain of functions. You can add in other parameters like a buffer size or things like that. So that's the basic idea of how you might use Graphical Modeler to start working with data in QGIS. The last thing I'll point out that if you want to see what the underlying code looks like, you can in fact click on this little Python icon right here, and it will open the Python code that's running underneath this graphical result. This is a kind of simplified graphical version. This is the code underneath it. So if you scroll down, you'll actually see here's where the buffer is, right? Here's where that clip is. And then the function, here's where you put in your input parameters, your things, and then it runs the actual clip function down here. So it gives you a sense of what the underlying code is. You could just run this over here in the processing toolbox if you wanted to. So that's a little bit kind of under the hood. I'm going to go ahead and discard this, and we'd have this. So hopefully that gives you a quick idea of how to use Graphical Modeler in QGIS.